Hello students, let us come to the next part of our chapter, that is properties of ether. First come to physical properties. Physical state. So the first two members, that is dimethyl ether and ethyl methyl ether, these are gases at room temperature, while higher ethers are liquid at room temperature having characteristics ethereal smell. Next, polar nature. So you know ether is represented as ROR. Here the oxygen atom has 2 lone pair and 2 bond pair electrons. Due to this is a non-linear molecule, hence polar in nature. Although this is a non-linear and polar in nature, although this is polar in nature, these ethers are insoluble in water. These are insoluble in water. However, the lower member, that is dimethyl ether, is soluble to some extent, and ethyl and diethyl ether, this is also very less soluble, about 7 gram per 100 ml of water. The solubility decreases with increase in the molecular mass as the alkyl group increases. So due to lack of hydrogen bonding, these are insoluble in water, although these are polar in nature. Next, due to this lack of hydrogen bonding, they also possess lower boiling point. They also possess lower boiling point. The lower boiling point is due to hydrogen bonding, and they have the low boiling point as compared to corresponding alcohols, aldehydes, ketones and carboxylic acids. And these are volatile and highly inflammable in nature. Okay, so the first two members are gases, all other are liquids at room temperature having characteristics ethereal smell. These are polar in nature and non-linear molecules. These are insoluble in water due to lack of hydrogen bonding. They have very low boiling point due to lack of hydrogen bonding. These are volatile and inflammable in nature. Next come to chemical properties. So, ethers are generally represented as ROR. There is no active site in ether as in that of alcohol and phenol. In alcohol and phenol, there is one hydrogen atom, this is the active site, and there are 2 alkyl groups, there is no active site. Hence, ethers are generally inert at room temperature. They do not react with acids, oxidizing agents, reducing agents, etc. under ordinary condition. However, under drastic condition, they also react. And the reactions of ether involves due to following points. That is, reactions involving cleavage of CO bond, reactions involving alkyl group, reactions due to ethereal oxygen, electrophilic substitution reaction in benzene ring. So the reactions involving the cleavage of CO1, reactions involving the alkyl groups, reaction due to ethereal oxygen, and electrophilic substitution reaction in benzene ring. Let us discuss the first one, reactions involving cleavage of CO bond. First, reaction with halogen acids. HX reaction. So when the ethers reacts with halogen acids, the breaking of CO bond, RO bond takes place, and it gives corresponding alcohol and an alkyl halide. The reactivity of different halogen acids follows HI greater than HBr greater than HCl. HCl is very less reactive towards the cleavage of CO bond, and HI is highly reactive towards the cleavage of CO bond. So reaction with, let's consider reaction with HI. Reaction with hydrogen iodide. So ethers reacts with hydrogen iodide or hydroiodic acid in two stages. First, if less amount of hydrogen iodide is taken, it gives a mixture of alcohol and alkyl iodide. It gives a mixture of alcohol and alkyl iodide. If excess of hydrogen iodide is taken, then the alcohol again reacts with halogen acids to form the corresponding alkyl iodide. Look at this example. C2H5O, C2H5 plus HI give rise to C2H5OH plus C2H5I. Here bond breaking takes place, H plus, I minus, H plus combines with here to form ethanol, and this is your ethyl iodide. This is this is diethyl ether. So when diethyl ether reacts with halogen acid, it gives ethanol and ethyl iodide. If excess of HI is taken, then this alcohol again reacts with halogen acids to form ethyl iodide. So the net reaction I can write like this: C2H5O, C2H5 plus 2HI, this is excess, give rise to 2C2H5I plus H2O, ethyl iodide. Again I repeat, when diethyl ether reacts with halogen acid, it forms ethanol and ethyl iodide. If excess of HI is taken, then this alcohol again reacts with HI to form ethyl iodide. So diethyl ether reacts with HI to form ethyl iodide and water. Okay. So if it is a symmetrical ether, then there is no problem where hydrogen is attached and where iodine is attached. Iodide ion and H plus ion and I minus ion, where it is attached or linked, that is no matter. But if it is a mixed ether or unsymmetrical ether, then the iodide part or the I minus is always linked with lower alkyl group. then the I minus is always linked with the lower alkyl group. Okay? Again I repeat, if we take unsymmetrical ether, then the I minus ion, iodide ion, is linked with the lower alkyl group. Look at this example, CH3O C2H5, ethyl methyl ether, or we can say methoxy ethane. When it reacts with HI, it gives, so here the bond breaking takes place and I minus comes here and H plus comes here. In this way it forms CH3I plus C2H5OH. That is your methyl iodide, and this is your ethanol. Okay, again I repeat, when unsymmetrical ether is taken and when it reacts with HI, then the I minus is linked towards lower alkyl group where it is less sterically hindered. Similarly, another example, OCH3. This is anisole, or we can say methoxybenzene. When react with HI, it gives phenol plus CH3I, phenol plus methyl iodide. So you know here iodine cannot, here HI reacts to form phenol and methyl iodide. Here I minus do not form phenyl iodide because you know this CO bond has some double bond character and it is difficult to break as it has higher bond energy. The CO, here the carbon atom is sp2 hybridized, here the carbon atom is sp3 hybridized. This is sp2 hybridized, this is sp3 hybridized. The CO bond has less bond energy than this CO bond because it has partial double bond character, due to which this here bond breaking do not takes place and bond breaking takes place here. So here I minus and H comes here. Okay, it forms phenol and methyl iodide. So bond breaking takes place here, CO bond. But if one of the alkyl group is a tertiary alkyl group, that is, if we consider about tertiary butyl and methyl ether, tertiary butyl and methyl ether, like CH3, C, CH3, CH3O, CH3 plus HI dot butyl methyl ether. Then although this is a smaller group and this is a larger group, here the I minus link towards this because you know tertiary carbocation is more stable than primary carbocation. As the tertiary carbocation is more stable, so in this way bond breaking takes place here instead of here. Here the bond breaking takes place here and it forms CH3, C, CH3, CH3I plus CH3OH. This one methanol and this is tertiary butyl iodide. Tertiary butyl iodide, and so whenever reaction of HI takes place, then iodide ion is always linked towards lower alkyl group. But if one of the alkyl group is a tertiary alkyl group, then the iodide ion is linked towards this tertiary group, because the tertiary carbocation is more stable than the primary carbocation. Okay. Let us consider the other reactions where cleavage of CO bond takes place. Reaction with sulfuric acid. When ethers react with dilute sulfuric acid, it undergoes hydrolysis to form alcohol. Look at the example. Diethyl ether plus water, sulfuric acid, it undergo hydrolysis to form alcohol to ethanol. So when ether heated with dilute sulfuric acid, it forms ethanol. But if we take concentrated sulfuric acid, it forms a mixture of alcohol and alkyl hydrogen sulfate. It forms a mixture of alcohol and alkyl hydrogen sulfate. Concentrated H2SO4 gives OH plus ethyl hydrogen sulfate ethanol. So when ether heated with concentrated sulfuric acid, it forms a mixture of ethanol and ethyl hydrogen sulfate. But if you take dilute sulfuric acid, then it forms only alcohol. Okay. Next come to another reaction with phosphorus pentachloride. Reaction with PCl5. When ethers are heated with phosphorus pentachloride, it forms alkyl chloride. Or if we take diethyl ether, then it forms ethyl chloride, and the side product phosphoryl chloride. Diethyl ether plus PCl5, when it is heated, it gives bond breaking takes place here and here. It forms 2C2H5Cl plus POCl3, ethyl chloride. So when ethers heated with phosphorus pentachloride, it forms ethyl chloride and phosphoryl chloride. Next, reactions with acid chloride and acid anhydride. Reaction with acid chloride and acid anhydride. So when ethers reacts with acid chloride or acid anhydride, in presence of anhydrous zinc chloride. When ethers reacts with either acid chloride, first it reacts with acid chloride in presence of anhydrous zinc chloride, then it forms alkyl chloride, and an ester. When ether reacts with acid chloride in presence of anhydrous zinc chloride, it forms alkyl chloride and an ester. But under such condition, if it reacts with acid anhydride, then only esters are formed. Look at the equations. Anhydrous and heat. So bond breaking takes place here. Chlorine and CH3CO. This is your acetyl chloride. Acetyl chloride, and this is diethyl ether. It forms plus ethyl acetate, ethyl chloride. When diethyl ether reacts with acetyl chloride, diethyl ether reacts with acetyl chloride in presence of anhydrous zinc chloride, then it forms ethyl chloride and ethyl acetate. Next, reaction with acid anhydride. This is known as your acid anhydride, acetic anhydride. So, when it reacts with when diethyl ether reacts with acetic anhydride in presence of anhydrous zinc chloride, then bond breaking takes place here. So this part forms one ester and this part forms another ester. In this way it gives 2 CH3 COO C2H5 ethyl acetate. When diethyl ether reacts with acetic anhydride, then it forms acetic anhydride in presence of anhydrous zinc chloride, then it forms ethyl acetate and ester is formed. Okay. Then come to reaction with heating with aluminium oxide. So when diethyl ether heated with aluminium oxide at 600 Kelvin, it undergo dehydration to form an alkene. Look at the example. Here elimination of water takes place and it forms CH2 double bond CH2 ethene. So when an ether heated with aluminum oxide at 600 Kelvin, it forms an ethene. Next, reaction with carbon monoxide. When an ether heated with carbon monoxide, or when an ether treated with carbon monoxide at high temperature and high pressure, when an ether treated with carbon monoxide at high temperature and pressure, insertion of carbon monoxide takes place and it forms an ester. Plus carbon monoxide, high temperature, pressure. So when diethyl ether treated with carbon monoxide at high temperature and pressure, here insertion of one CO bond is inserted here, CO molecule inserted here, insertion of CO takes place and it forms an ester. So when diethyl ether treated with carbon monoxide at high temperature and pressure, it forms ethyl propanoate. So these are the reactions where cleavage of CO bond takes place.